Welcome back to Ask Jerry and Ray Anything About IBM Z. I'm Ray,
I'm Jerry.
and today we're going to ask, what makes this JCL fancy?
All right. So today we're going to look at conditional logic in JCL that includes if then, and then else, and then end if. Then we'll look at the purpose and benefits of symbolic parameters. IBM has made some significant enhancements in that area. Then we'll look at proc enhancements, access and flexibility within procs, with a special emphasis on in-stream procedures. And then we'll close out with JCL Live order enhancements. So Ray's going to kick us off with conditional logic.
So, conditional logic in JCL, very similar to most other programming languages. You have an if, then, else. This one requires an end if. Some languages do, some don't. So just keep that one in mind. But again, it's a very simple, when you think about it, very simple logic, but very powerful. In this example here, we're looking at, a very rudimentary thing of JCL. It's not fully formed out like we've discussed in the last couple sessions, but, this just gives you an idea, right? When you run step one, it does some program, and it gets a return code. And before we run step two, we check to see if step one got a return code greater than 4. Typically, a return code of 4 is, there was a warning, but you're probably okay. You kind of have to know what program you're running before that, just to make sure that when you're writing these conditional statements, you don't accidentally go ahead when there was what should have been a stopping error. But anyway, we check step 1 return code. If it's greater than 4, then we execute a program called error hand, and it takes care of the errors. Otherwise, we run a program called continue, and then there's our end if. And you'll notice on here that the if, else, and end if are not the names of what's called a label, which is the text that immediately follows the 2 slashes. And so labels are just that. They're labels, right? They're not interpreted as actual code. So just make sure you've got at least one space between the 2 slashes and your else and end if. And then that's both jumping on my desk now. And so what you can do with this is you can test return codes. You can check if there was an abend condition. You can even check the abend condition code. And then something called a run status. That one I've actually not used before, Jerry. What is a run status?
Yeah, that's an interesting one. That allows you to check whether a step has actually run. So it's possible that that step was bypassed for whatever reason. If it hasn't run, then you can act accordingly. So
Okay.
that's something that never existed before.
Yeah, and that's another thing is they just keep adding things to JCL to make it more robust, even though it is already fairly comprehensive. And you can do compound logic using and or statements. And then the really difficult one that I've tried to use before, and I usually get it wrong the first 3 times I try to run it, is using a cond equal statement on a step, because it's almost like backwards logic, and I could never really wrap my head around it. So I would usually have to test the program 2 or 3 times to make sure I actually got the cond equal statement correct. So it's a lot better that we're moving more into traditional programming if then else kind of statements, and away from this confusing cond equal statement.
And I laugh, Ray, because as a systems programmer, I would have people come to me almost in tears because they could not get that cond equals working right. And like Ray said, it's
Yeah.
backward thinking. Okay, I only want this step, I want this step to be bypassed if this condition is true. And so you got to say, okay, now what makes me want this bypass? That's if I get a return code 4, and people just kind of threw up their hands and said, I just can't get it right. So I kind of walked them through it, tossed them in off the ledge, and got them through it. Because this if then else, that's fairly new. That hasn't always been there, and I think I saw that it was like in the beginning of this century that they added this kind of capability. So, all
And
right,
I'm sure glad they did.
absolutely. All right, so let's move on. We'll look at the purpose and benefits of symbolic parameters. So first, what are uh, the purposes of symbolic parameters? It allows you to parameterize, we made up a verb there, JCL for reuse. So rather than having hard-coded data sets or dates or options at runtime, you can specify a parameter and use that same parameter everywhere where you want to reference that particular data set or date or whatever it is that you want to refer to several times in your JCL. It also allows you to centralize maintenance. So what does that mean? Okay, rather than me having to go through and in my JCL do a change all command to change all dataset 1 to dataset 2, I can just go into one place, change that symbol name from dataset 1 to dataset 2, and then it's now always the same throughout the JCL. And it also allows me flexibility to adapt across environments. I can have a environment variable. So all my jobs are going to run in production. I could have env equals prod. For a test, I can say test. For development, I can say development. And so then we have prod data sets, we have test data sets, we have development data sets, and we would then reference all the correct data sets and not accidentally touch a production data set when we're doing a test run. And so this gives you a lot of flexibility and makes your life simpler, uh, in my way of thinking.
Now, can you actually combine that with the if then else statements so that, if environment equals prod, then set this variable to this value?
Well, you could do that, but I think there's a better way, and I think they show us that, or we show that later on.
Okay.
Okay. Um, so what's a symbolic parameter? I set ampersand date equal to a value. And then I can use it in names and values. So here I set my ampersand date equal to DT240601. There's a Julian date of year 24, month 6, day 1. And then when I reference it, I say account.report.ampersand date. Well, it's going to stick DT240601 as a low level qualifier for that data set. Uh, we looked at this and we said, well, if it's the low level qualifier, you don't have to have a period after it. If it's somewhere in between, you have to have not one period, but two, if that's the way that you want it to go. So that's something that you have to watch out for using these symbolic parameters. We also see here, we set the region equal to 0 meg, and when I execute the prop, I set my region equals ampersand region. If I decide I want to change that, I change it in one place, and it's changed everywhere in the JCL. Now, this is what I was talking about earlier, where you have an environment variable, and then you have another variable that has corp dot and the environment.
Okay.
So if you had all of these in this particular job, every reference to this will reference the QA data set. Then if I had a job that was production, I would just say env equals prod, and all of them would then reference the production data set. So you could use a if then else, but this gives it to you, bam, you got it. You set it up front, and it's correct all throughout your JCL.
Parameterize the parameters.
Yes, yes. So you got to build up on it, and it makes life very simple. You know, once like you say, once you get it all squared away. I've gone through and I said, "What do you mean it didn't run?" Oh, I'm sorry. I see that I made a mistake because I'm always arguing with the system. And unfortunately, the system always wins. That's been my experience. But
Yeah.
that's what you can do with symbolic parameters.
Yeah, a system does what you tell it to do, not what you want it to do necessarily.
Exactly. And then it looks at you silly because it said, "Well, look, I just did what you told me to do," and so. All right. So let's take a look at proc enhancements.
Yep. So proc enhancements, again, it's kind of a parameterization of it, where in this example, you can see that you have, the proc is very short here at the top, and you got basically step one, executing program step one program, and step B, executing program step two program. And then append is the proc end. So you almost always need a proc and append statement paired together. Sometimes in started tasks they don't do that, but personally I think it's better programming housekeeping, we'll say, to make sure you have your paired statements. And so
Let me
then,
interject. This
yeah,
is a data set that's in a PROCLIB data set as opposed to an in-stream proc. We'll see the in-stream, and the way that I know that is the job card is after that proc. So they show you what the
okay,
proc itself looks like, but it's not a part of the job stream. So,
okay,
so
okay. Yeah, I thought this was one of those where you define the proc at the top, and then at the bottom it kind of submitted like a second job to do that. But yeah, you're right. If it was in stream, the job job card would be at the top. But so yeah, here the actual job that you submit will execute my proc, and then going back to the earlier if then else, you check to see if the job one step A return code is greater than 0, and if not, I'm sorry, if it is greater than 0, then you run a program called fix it. Again, error handling to make sure that you housekeep, keep things nice and tidy. And then there's your end if statement.
well, let me step in and eat the little crow, have little feathers sticking out of my mouth.
Uh
For
oh.
whatever reason, we chose job one as the step name. Now, so that totally threw me off. But yeah, so that's the step name. So step name dot step in the proc dot return code. So that's just a little confusing to me because we have weird JCL just to make life interesting. So yeah, so I guess this would be considered an in-stream proc since that's a step name, not a job name. So
Yeah. Yet another example of why you should have some kind of standards with your JCL and your jobs and any program you write, and kind of adhere to those standards. Otherwise, uh, things get a little confusing.
yes, all right.
But yeah. But setting it up this way allows you to do kind of more powerful overrides in case of errors again, to step in and try and fix it before you move on to the next step.
All right.
And so now we talk about in-stream procedures, which kind of was a little bit of an example on the previous slide, but what it does is inside the job, so you've got the job statement at top, and then you have your prox. Oh,
That's right.
yeah. And then because again, inline, right? So you have your job statement at the top, then you have your proc statement, you define all your procedure items, where again, you have however many steps you need, up to 256, and then you have your actual execute proc statement at the bottom of the JCL, and you can have additional things in that job where you have you might have some more steps that run afterwards. Um, but usually an in-stream proc, all it does is it calls itself at the bottom and then runs with these substituted variables and any other enhancements to the job. And so, why do you want to do this? Well, you can make things easier because, again, you're defining it as a parameterized job, a parameterized application. And so, if you need to change something, change it from, dev to QA to prod, all you have to do is update one location. You change the data set name, change it in one location. Because, yeah, doing a change all, if you accidentally do something wrong, that one job will run correctly. But if you're running another job after it, it might be looking for something else that you just didn't type right. So, again, you're just trying to reduce the potential for human errors. So again, these are kind of best for transient or ad hoc jobs that you're kind of running just one at a time usually. Even though I just said you want to make sure that any downstream jobs are running correctly, but again, at the same time, you can use them for really however you want to use it. It's your system.
Exactly. All right.
And again, just kind of going through these real quickly because, we've already talked about, it's a faster job setup. You write it once, you make one change, and then if you need to use it in multiple different environments, copy the job, make one update, and you're good to go in the next environment. There's reduced maintenance because if you have issues with it, you make an update in one location and you rerun it. Improved change control. Some companies really lock down their change control. And so if you're on a tight timeline in your maintenance window, fewer things to change. And this one seems a little bit backwards, but limited reuse kind of makes it harder for people to misappropriate the job because it's kind of made for one purpose. And so use it. You can use it in different environments, but it does one thing. And kind of with coding standards, you want to have as little in each function, each application, each module, so that if you need to reuse it for something or make changes to it, you don't have to make a ton of changes.
All right.
And this is a little bit more of a description of what we had mentioned, where the job name is at the top, then you got the proc where you define it, and then you have all the different steps it does, and then your pend statement. And then the job calls itself. So what this does is removes the necessity for having a job lib or a PROCLIB statement within the JCL itself, because the proc is self-contained. And again, it's best for jobs you run once every now and then, or if I have a JCL library that I've taken with me from, I don't even know how many different employers I've had it at, but yeah, you just take it from one place to another, you make a couple minor changes, and it's good to go. And again, it supports your if-then-else statements, so it fully goes along with the new standards that are being added in and new enhancements.
All right.
Speaking of enhancements,
we can look at JCL Live Order. I was so excited, I clicked a little soon. And what exactly is JCL Live? JCL Live. It allows you to specify your own PROCLIB data sets. We have in-stream procs. You put the proc inside the job itself, or this gives you the ability to have a PROCLIB data set of your very own. And so you set up a layer of PROCLIBs. So you can say, I want to look at data set 1 and data set 2 and data set 3. If it's in data set 1, okay, it executes that proc, off it goes. If it doesn't find the proc in data set 1, it looks in data set 2. And then finally it looks in data set 3. Now I said data set 1, 2, and 3, they've got a top layer, middle layer, base layer, same concept. Layer 1, 2, 3, 4, it's the same concept. And you got all kinds of different ways to arrange this. But you have complete control over what gets executed by the way that you specify the proc live data set. I'm sorry, the JCL live data set. Okay, so this is what we were talking about. If it isn't found in the first one, it looks in the next one, it looks in the next one, and then finally, I think it'll look in the real JES2 PROCLIB data set if it hasn't found it yet. So if you have a real system level proc, it'll look through all your data sets, say, nope, I don't see it there, don't see it there, don't see it there. Okay, let me go look in the system PROCLIB data set. Ah, there it is, and it'll pick it up and run with it. And so we talked about separating your dev, test, and production. It's similar to the in-stream procs. It improves change management, and when you have to move procedures across the environment, that can be a nightmare. This will make it a lot simpler, and then you can see what's happening. That's the best visual. And so this is an example of a JCL live statement. Usually you put that right at the beginning of the job, and you say, I want to look in prod first, prod.proclib first. If it's not there, I want to look in qa.proclib, and then finally, I want to look in dev.proclib. You have multiple data sets in the concatenation. You have automatic fallback to lower environments. So if you move something to production and find out there's a problem with it, then when you run that job again, you can remove it from that production prod live, run it again, it'll then pick up that proc from another place. So, and so that gives you the ability to simplify versioning and controlled rollout. So you say, okay, we're going production tomorrow. We're going to put this proc in production. And for whatever reason, something goes astray, then you can go back to, you can remove it from the production proc lib, and it'll pick it up from the QA proc lib. If there's a problem with the QA, you can remove it from there, it'll pick it up from dev. So you go right down the line. It looks in each data set until it finds it. And we're at the conclusion. And this is the heart of FANCY JCL, is flexibility. You got if then else logic, and you don't have to try to figure out how to use cond equals. Cond equals, I think, came along with with Noah after Noah got off the ark, but it's been around for a very long time, and people have always complained of, that it doesn't make sense. What do you mean? And so IBM has made it simpler, and you can understand exactly, if the return code equals this, or if the return code from this step equals this. I use it because I expect all of the previous return codes to be 0. If any one of them is not 0, then I want to fail the job. So I say if RC, I don't even specify a step. I just say if RC is not equal to 0, it'll say, okay, this got 0, this got 0, this got 0, you're good to go, and it proceeds. If I get a non-zero return code, then it's going to do the failure step. Symbols and set allows you to use parameterization to make your JCL easier to reuse, maintain, and standardize, but also to read. Okay, if I've got JCL and I've got ampersand env dot ampersand test, then okay, yeah, I know that I'm looking at this environment, I'm looking at this test, I can see it specified there. And so when I look at that, read that JCL, I understand exactly what's happening. The proc enhancements, uh, the ability to go back and check the return code inside of a proc, that is a great amount of flexibility that you didn't have before. You have to. It used to be very complicated. You could get to it, but it just wasn't. It just didn't make sense. But now you can go back and say, if the return code from this step in this proc is 0, here's what I want you to do. And then finally, we looked at as a uh, offset of proc enhancement. We talked about in-stream procedures. So you can write procedures of your own that you put inside your JCL, and that takes care of things. We also talked about JCL Live in order and the ability to work your way down through a bunch of data sets and decide, okay, this is the proc, this is the data set that I want to get this proc from because I didn't find it before that point. So, so that is the end of our trilogy about JCL. We talked about what JCL is. We showed you simple JCL, and then we closed it out with fancy JCL. So
Ooh.
next week we'll find something else that we hope will be of interest to you, and we want you to join us at that time. Remember to click that subscribe button if you haven't already. Click a like if you like this, and we'll do more things like that. And send in any questions you might have. And so we'll conclude our session, our podcast for the day, and we'll talk to you next time.
Yep. And as always, if there's something you want us to talk about, just drop it down in the comments. We'll make a session on it.